Today I'm going to tell you everything you need to know about calculus. Right, in simple terms, for calculus we've got differentiation and integration. Now differentiation is the way we find the rate of change of the gradient of a line. Integration is the way we find the area underneath a line. So how do we work this out? I'm going to give you a simple example. We're going to use a simple graph, the most simple graph I can possibly think of. Here it is. Make sure the line's big enough. There you go. The most simple graph I can think of. In this case, this is our y-axis, this is our x-axis, and our gradient of our line is simply, let's say this is 15, y is 15 there, and x is 15 there. That means at that point the coordinates for that point there is 15 and 15. That means, right, if we look at this, we have a square or half a square. This is the area under the line. Now we can work out using calculus the area under the line and the rate of change of that line. Now you might be asking, why would we do this? Because we could simply use geometry. We could simply find the area of the square and cut it in half. We're going to use calculus because this is the point of the video. So let's have a look at it. In this case, at any point on the line, any point of x all the way down here, whatever x may be, y will be the same value. That means that the equation or the function for this line is y is equal to x. And there we have it. There's our start. So let's take this and we'll just move it out the way. So to write this as an integral equation, we have to have our integral sign, our limits, which are 0 to 15. That's the limits on the x-axis. That means we're going from 0 to 15 along there. They're our limits for this line. Our function is x, y is equal to x, and we're going to differentiate it with respect to x. When we differentiate, we're going to integrate with respect to x. So what do we do here? Well, this is the formula, right? If we've got x to the power of n, when we integrate, we add 1 to the n, and we divide by n plus 1. For this function, x is to the power of 1, because any value to the power of 1 is itself. So in this case, to integrate x, we have to add 1 and then divide by 1 plus 1. So we get x squared over 2. Now we need to put this into our formula with the limits. So we get x squared over 2 minus x squared over 2 when the limits are 0 and 15. So that's our equation. How are we going to put numbers into this to get our answer? Essentially what we're going to do is we're going to replace x in the left hand side with 15 and on the right hand side with 0. So we get 15 squared over 2 minus 0 squared over 2. And the result of that equation, so let's do a quick calculation, and we get 112.5. Now that is the area under the line on that graph. So now the handy thing about this is we didn't need to use 0 to 15 as our limits. We could have used any section we like. We could have had from there to there. If we assume those limits are 7 and 10, right? If we write our formula then, instead of with 15 and 0, if we wrote it with 10 and 7, we'll get the area under the line that we shaded in black there. Let's have a look at what we actually get. So in this case we get That's 25.5 is the area within that distance. So we can use integration to find lots of different kind of information just by knowing how to do this little bit here. So the next thing we need to be able to do is differentiation. We use this structure, dy by dx. Now in this case, y is equal to x. We've got this. So essentially what we've got is dx to the power of 1 over dx. Now the rules of integration, we've got different, this here was our integration. Now for differentiation, x to the n, we're going to do almost the opposite. Instead of adding 1 to the power, we're going to minus 1 from the power. Then, instead of dividing by n minus 1, we're going to times by n, like that. So, in that case, this formula here, when we differentiate, becomes x to the power of 1 becomes x to the power of 0, and we bring the 1 down in front, like that. So essentially, what we've got, x anything to the power of 0 is 1. So this essentially is 1 times 1. So we have a gradient of 1 for our line. Now let's assume that this was a velocity time graph, where we've got x is our time and y is our velocity. So essentially here we're going from 0 meters per second to 15 meters per second on the y-axis in 15 seconds on the x-axis. That means that the area under the line tells us the distance we've travelled in that time. And we got for the distance we've travelled 112 meters. And then for the rate of change of speed, which is the gradient of the line, we have 1 meter per second squared. So that's how we use integration and differentiation. Look out for the next video for an example which is going to expand on this a little bit.